Okay, let's take a look at our Unit 4 review. The first problem here wants us to look at this cubic polynomial, this degree 3 polynomial. It says use long division to determine whether the given binomial is a factor of f of x. So we've got x minus 3 here that we're looking at as a factor. So if it's a factor, then it's going to be divisible by x minus 3, this cubic, right? We should be able to divide into it without a remainder. All right, with that said, let's go ahead and check that. We'll use long division. Of course, with this divisor, the form x minus 3, you could easily do it synthetically. But we're going to do a couple examples here with long division. Start off with. Let's go ahead and divide. Let's see if it is divisible by x minus 3. So as we set up our long division, all right, we're going to divide into this cubic polynomial. Now, if we have any missing terms, we want to put those in. Now, in this cubic polynomial, we don't have any missing terms. All right, so let's go ahead and start dividing. So as we're looking at dividing, let's put in a different color here. We look at our first term and our divisor, and our first term and our dividend. And we ask ourselves, how many times does x divide into x cubed? X divides into x cubed exactly x squared times, right? X squared times x is the x cubed that we're looking for. And we'll go ahead and distribute x squared times negative 3. That's a negative 3x squared. And then after we divide, we see what's left over here in our dividend. So we subtract. Of course, x cubed minus x cubed, that's 0. Negative 12x squared minus negative 3x squared ends up making that a plus, right? As we subtract that, it ends up making it a positive. So that'll be a negative 9x squared after we subtract the negative 3x squared from it. So minus minus makes a plus. And then we'll continue dividing. So now our dividend is a quadratic. Let's go ahead and bring down the next term in our dividend, the x term. And let's go back to our question. All right, we're asking ourselves how many times does our first term in our divisor, which is x, divide into our next term in our dividend, which is negative 9x squared. We know x divides into negative 9x squared exactly negative 9x times, right? And negative 9x times x is the negative 9x squared that we're looking for. Negative 9x times negative 3 is the positive 27x as we multiply. And then we subtract and see what's left over. They cancel out. We know that 35x minus 27x is a 8x. And as we look now, our dividends down to a linear expression. Let's go ahead and bring down the next term in dividend, which is the constant term, minus 24. All right, as we go ahead and divide again, we're looking at our first term in our divisor, x, and our first term in dividend now 8x. Well, x divides into 8x exactly 8 times. All right, we know that 8 times x is the 8x that we're looking for. We know that 8 times negative 3 is negative 24. And as you can see, as we subtract, all right, what do we get? We get 0. So our remainder is 0. So if our remainder is 0, that implies x minus 3 is a factor of this cubic polynomial. That implies x minus 3 is a factor of f of x. Right? It's divisible by x minus 3. Right? And again, we can show why. We know when we check division, divisor times quotient, right, always equals remainder. X minus 3 times x squared minus 9x plus 8, right, gives us that cubic polynomial that we're looking at. What gives us x cubed minus 12x squared plus 35x minus 24. Right? Again, divisor times quotient, right, gives us our dividend. So again, we can always check. So here's our divisor. I'll make a note of that. And here's our quotient. right? It's quadratic polynomial. And of course, that's our dividend, what we divide it into. That's f of x. With that said, yes, x minus 3 is a factor of f of x. X squared minus 9x plus 8 is a factor. So if you wanted, you could even break it down into its 3 linear factors now, because all of us know how to factor this cubic, or this quadratic. Every quadratic has 2 linear factors. We know with this one we can factor it easily with integers. We need an x and an x up front for the x squared terms. We know the factors of 8 that work together to make 9 or negative 9 or 1 and 8. We just need to make them both minus. Right? If we did that, we see that's x squared minus 9x plus 8 as we multiply it out. So there are 3 linear factors, which a degree 3 cubic polynomial has. So x minus 3, x minus 1, x minus 8, right? Those are all factors. The factors of f of x. Degree 3 polynomial, and we'll make that note. Degree 3 polynomial implies 3 linear factors. And we found those using division, polynomial division. So yes, x minus 3 is a factor, and the reason for that is the remainder is 0. All right, let's do one more. Let's go to our next example. As we look at example 2, we've got a degree 4 quartic polynomial, and it has 4 linear factors. And it wants to know if x plus 2 is one of those linear factors. So let's set it up. Let's do long division again. So x plus 2 divided into this quartic. Now with that said, do we have any missing terms? If so, we want to put in those placeholders. This one again does not have a missing term, so there's no placeholders that we need to put in. We want to do that so the division works out nicely. But let's go ahead and divide. X divides into x to the 4th power, exactly x cubed times, right? X cubed times x is x to the 4th power. X cubed times 2 is 2x cubed. And as we subtract and see what's left over, those cancel. Negative x cubed minus the 2x cubed, that gives me a negative 3x cubed. And then we bring down the next term in our dividend. Right, we're now looking at a cubic polynomial in our dividend as we start with a quartic. And let's go ahead and divide. How many times is x dividing negative 3x cubed times negative 3x squared times, right, exactly. Negative 3x squared times x is the negative 3x cubed that we're looking for. Negative 3x squared times 2 is negative 6x squared. As we subtract to see what's left over, of course, they cancel. Negative 3x squared minus the negative 6x squared, that makes a plus, that makes a 3x squared. We subtract those terms, and we bring down the x term, the 4x, and we continue to divide. All right, let's go ahead and do that. How many times does x, our first term of divisor, divide into our first term of dividend now, which is 3x squared? Exactly 3x times. We know that 3x times x is the 3x squared that we're looking for. 3x times 2 is 6x. As we go ahead and subtract, what do we have left over? They cancel. 4x minus 6x is negative 2x. As we bring down the next term, which is our last term, our last step in the division, let's go ahead and divide. Well, as we divide here, we know that x divides into negative 2x exactly negative 2 times. Right? We know that negative 2 times x is negative 2x. We know that negative 2 times 2 is negative 4. And as we subtract, what's left over is our remainder. And 7 minus negative 4 is 7 plus 4. Right? As we subtract that, we get 11. So 11 is equal to our remainder. Well, our remainder in this example is not equal to 0. So if it's not equal to 0, that implies x plus 2 is not a factor. Not a factor of f of x. So again, our remainder needs to be 0. It's not. It was 11. So again, with that said, right, we're looking at degree 4 polynomial where x plus 2 is not one of the 4 linear factors that it has. So these two examples, you can see the factors that were given as we're testing with division. One of them worked, one of them didn't work. Right, and the one that did work, we were able to go ahead and continue breaking it down all the way into its linear factorization. Right?